This brief presentation will cover the development of the earthing services product range, including case studies. Once you have watched this, please contact us with any questions. From our discussions with several HSE inspectors following either utility strikes or other RIDDOR reportable incidents associated with earth rods, we have captured this summary. Their chief concerns relating to earth rods amount to the risks of hitting subsurface elements, particularly utilities, the hazards associated with the physical installation, and the ongoing reliance on a safety measure that may have become insufficient through deterioration. Here we see evidence of copper earth plates, copper tapes, and earth rods that have deteriorated beyond usefulness. Whilst not shown, a lattice is not as substantial as a copper mat, and so would fail even more significantly by comparison to the same faults and environments. The earth rod we see here that has been blindly driven through a power cable resulted in the hospitalisation of a worker and financial penalties, along with the Riddle incident report. Here we see some pictures of corroded earthing materials from earth mats to earth rods. It is worth noting that the corroded rod down to the thread is the remains of a 1.2 metre UL approved copper bond rod after just 3 months in an area of saltwater migration and subject to frequent low level discharges. The quality of the rod is not in question. It was manufactured to the highest standard in the world by the leading manufacturer. The problem is the product itself. New products such as the Conjudisc will simply be dropped in at around 650 millimeters, meeting earthing standards and saving huge amounts of time and effort. Some companies do not use earth rods and instead use copper plates, lattice mats, or even bare cable. As copper is a non-ferrous metal, there is often a misunderstanding that it will not deteriorate. However, whenever there is an electrical discharge, there is electrolytic loss of the conductor. Here we see aging evidence from testing which demonstrates a bare copper plate and one encased in conjurcrete after repeated electrical discharges. As you can see, the bare plate has badly deteriorated. The plate encased in conjurcrete only has surface scarring that occurs during the binding process. The rate of electrolytic loss is substantially slower on conjurcrete than it is on bare metal, which results in a future-proofed conductor. If the bare plate had been a lattice, then there will be substantially less material present, so deterioration will be an even worse prospect. Any item now reliant on the now deteriorated plate would be at risk in the event of a fault that it can no longer manage, as would anyone in the vicinity of it. Remember, electrolytic discharges are unavoidable, and even adjacent discharges from other systems can badly affect a given system. Just a quick reminder on the nature of an electrode. Resistance to current through an earth electrode has 3 components. Number 1, resistance of the electrode itself and connections to it. Number 2, contact resistance between the electrode and the soil adjacent to it. And number 3, resistance of the surrounding earth. Other factors affecting performance are the total conductor footprint and the overall discharge zone and the conductor life cycle phase. The great debate. Can an earth rod be installed from surface level and still be compliant with governing standards? The wiring regulations cite BS 7430 as cross-reference for earthing matters. BS 7430 states, where these conductors are intended to reduce the value of the earth resistance, their minimum depth should be 600 millimeters. As such, any party relying on earth rods must first excavate down to this starting depth before commencing driving earth rods. Here we can see some of our products. The solutions we will see with these products embody our core values that safety is critical and time is money. And so by reducing risk and installation time enables rapid remobilization, which is why they are so hugely beneficial to our clients. Our products are designed to bind with the surrounding mass of Earth, not simply locate adjacent to it, making energy transfer faster and more effective. By encasing metallic elements in a larger and less reactive material, whether through ground hostility or discharges, they often outlast to hundreds of percent. Removing metallic elements is so difficult that it renders the scrap value worthless. Providing a larger contact surface area in a small footprint with lower contact resistance. All of our products are designed to be as fast, safe, and easy to install as possible, meaning deviations in performance resultant of poor installation are mitigated. Both Earthing Services and our partners SAE have a long history in the power sector in providing safe earthing designs, as well as developing products to support the safety of the network. Our solutions and expertise include corrosion control and effective earthing of direct buried metal, transmission and distribution poles, safety of third-party employees when they are working in the vicinity of live lines, review and design modifications of existing substations when additional fault current occurs due to connection of renewables. Corrosion control and effective earthing is achieved by combining innovative products with non-traditional delivery methods, such as volumetric mixers being used in North American installations, where the material is mixed as it leaves the truck, so there is no waste and holes are backfilled in minutes. Concrete is one of our most popular lines. It is supplied in powder form and in nearly all applications is installed simply by emptying the bag without any additives or water. It will absorb moisture from the native ground mass and cure to a concrete-like consistency. As with our other products, Concrete prevents theft and corrosion and is environmentally neutral and has been installed in environmentally protected areas. Concrete has been used to provide an earth on all manner of projects, including deep vertical electrode earthing, horizontal electrode earthing, distribution earthing, transmission earthing, substation earthing, and earthing system retrofits. The more challenging the environment, the greater the disparity in improved performance compared to others in the market. Here we see a comparison in the desert areas of Oman and Abu Dhabi. At the first site, Concrete achieved a resistance of 9.4 ohms compared to 93.6 using rods and marconite. And the second site, Concrete achieved 4.55 ohms compared to 87.43 using rods and marconite. What follows indicates the limits of the tests undertaken, not the product, which had no observable issues following any of the tests. These tests showed that Concrete offers a 30% improvement over marconite. Many case studies show a much greater improved performance. It affords significantly greater current density carrying capacity than copper alone, is undamaged after 3,200 amp thermal shock, eliminates electrolytic corrosion, has a 32.5 MPa compressive strength on average, provides adequate theft and vandalism protection, and it is environmentally neutral. Here we can see some extracts from the independent testing on Concrete. Full reports are available on request. Here we see a direct comparison between the use of Concrete and an alternative conductive concrete. Concrete is significantly faster and cheaper to use. We will now consider overcoming corrosion of direct buried steel in power transmission using Concrete. Here we see the corrosion of steel that has been buried. The traditional method of preventing corrosion on power transmitting direct buried steel is the application of insulating coatings. As the photographs demonstrate, these coatings are easily damaged when installing, and scratch points result in concentrated corrosion that then rapidly spreads. Our approach is different. Instead of insulating the steel from earth, encase it in a material which will safely discharge and protect the steel from deterioration. Pour in mixed concrete. Once cured, this will provide a safe electrical earth, preventing corrosion and ensuring stability. The conjudisc is a carbonaceous polymer with an equivalent contact surface area of a 3-meter earth rod and fault tested to 55,000 amps. This product is a far safer prospect to use and install than earth rods and encased copper plates. Increasingly, our clients are simply replacing earth rods with conjudis in their earthing system. The product is deterioration proof, reduces labour cost, requires no additional locations, requires no ongoing maintenance, affords significant savings from year 1 to year 60. Conjudis provides asset protection of 60 years, by comparison to rods and mats between 3 and 15 years, removes maintenance or replacement of earthing systems, so improves CapEx within 2 years and OpEx within 5 years, is a better asset protection and reliability by ensuring protection devices function as designed and reduction in resistance to ground. It has improved safety during installation and network maintenance and fault performance, reduced installation time and costs from 90% time reduction. It has been tested to withstand 155 kiloamp. It is not affected by aggressive soil conditions. Reduces or eliminates variation of the earthing system performance by different installers as the number of key steps and material variance is greatly reduced when compared to rods and earth mats. So, how does the conjudis compare to earth rods? When it comes to designing earthing systems, the industry standard software that we use is called CDEGS. Here we can see the first stage of a CDEGS comparison between traditional earth rods and the conjudisc. In this slide, we see the performance of a substation earthing system supported by 4-number 3.6 meter rods. And in this slide, we see those rods replaced with conjudiscs, which will be installed inside the cable trench, therefore removing the need for additional excavations or vertical driving. When the installation time and service life is compared here between the rods and the conjudisc, we can see that the conjudisc is a far more logical long-term proposition with a shorter installation time and a longer service life. Here is another time and motion comparison of traditional methods and the conjudisc, showing comparable performance but less time and manpower resources to install. We will now consider earthing for EV charging points. There are many different options for EV CP earthing. TT earthing provisions, including conjudisc, conjur-wire, conjurcrete, earth rods, earth plates, and earth lattices, open type devices, which operate as any other variety of RCD to divert fault current via the neutral conductor with the intention that it will be dispersed by inline earthing provisions of the PME. PME stands for Protective Multiple Earthing. PME is usually discussed as a robust network of earthing provisions that combine to provide a highly effective, safe, and long-term solution. Whilst we may conceive of the PME of comprising well-designed, installed, and maintained earthing provisions, it is rather less sophisticated. The PME is everything that can discharge current to earth in the network. So that's substation earthing, pot end, cable splice earthing, fortuitous connections from bonds to metal gas or water pipes, old PILC, or other metallic sheath cables. So what's the problem? The PME is unfortunately not maintained. Earthing conductors deteriorate either through use or hostile environments. DNOs invariably do not test or maintain their earthing provisions. Old metallic utility pipes are being replaced with plastic pipes, and old cables are replaced with plastic sheath cables. So sadly, the PME is a less reliable earthing method with every day that passes. Most DNOs do not test PME earths when installed. They aren't revisited for interim retesting or remediated during the service life. As such, longevity of whatever performance is achieved is presumably a point of concern that is desirable to improve, and it remains something that earthing services products can resolve. This is the latest iteration of the Conjudis, combining all of the advantages of a precast Conjudis Pro with emergent technology of the Conjuwire. The Conjudis Elite is the highest performance Conjudis currently available. Conjuwire is a conductive sheath corrosion resistant product. Conjuwire is available now. Here we can see an example of some bare 70mm square cable sheathed in a conductivity and longevity enhancing polymer. It can be supplied in spools to be cut and installed in line with usual methods. Conduwire can be used for LV and HV systems. In respect of LV work, contractors are often installing earth rods horizontally at cable joint pot ends, simply by laying them in the trench to the point of connection. The earth rods function poorly. Earth rods are often disturbed or removed by other disciplines. Conjuwire is easily installed and will function effectively in a small footprint. Here we can see that without any driving, short sections of conjuwire will outperform a conventional earth rod. And here is a demonstration of the considerable corrosion resistance benefits of using the conjuwire over conventional bare wire. We'll briefly move on to ConjuFlow, which is a liquid backfill that cures over a number of hours. These are some of the specific attributes of ConjuFlow, which is often installed in conjunction with ConjuDiscs. These include: it is pourable, it eliminates electrode corrosion, it is environmentally neutral with stable year-round performance. ConjuFlow is ideal for a range of applications, including as an earth enhancement material in difficult or corrosive environments, for transmission structures, cab mount transformers, substations, retrofit of existing earthing systems. This product is supplied in two parts, being the main conductive element and a curing agent, which solidifies the ConjuFlow over a number of hours. Much like the ConjuDisc, whilst these are suggested applications, the product itself can be used to provide an earth for anything. We're now going to look at Conjuform, which is a putty type consistency when applied that solidifies very quickly. Conjuform can be used to glue electrodes onto bare rock. In such applications, it has seen a bare copper conductor measuring in the thousands of ohms, reduced to less than 50 ohms simply by applying the Conjuform. As you might imagine, it is far easier to cover a conductor than it is to excavate down to install one. If required, berming can disguise the Conjuform for aesthetic reasons. Here we see Conjuform installed on a bare rock on a 45-degree angle. Other products would simply slide off, but Conjuform holds firm and then solidifies. In this given example, they had tried to use regular concrete, which did simply slide off. Conjuform has even been used in vertical applications where it was adhered around the surface of a large boulder and it held firm. Conjuform reduced an existing system's resistance from 1000 ohms to 200 ohms in a matter of hours and 132 ohms once cured in an area of bare rock. And here you can see Conjuform covering a conjudisc that has been placed flat upon the rock. We're now going to consider the marine electrode, the most effective way to achieve resistance even without connection to land. The marine electrode has the following attributes. It is easy to install, can be specified for fresh and saltwater environments. Unlike historical approaches to marine earthing, the marine electrode has a long service life without deterioration. It enables marinas or aquatic based structures to be earthed without connection to the mainland. It can be used in conjunction with our other products to extend land-based earthing systems into bodies of water to achieve a target resistance. It achieves functional contact and embeds over time into the base silt layer. This is an example installation of the marine electrode, which was earthing 21-metre and 16-metre masts situated on a jetty 200 metres out into the sea on the south coast of the UK. These marine electrodes achieved 3.07 ohms and 3.10 ohms respectively. Client testimonials substantiating the statements made within the presentation, and a thorough exploration and user feedback from the E5 group. You don't have to take our word for it. Here you can see our business case overview. It is important to note that new products are always in the pipeline. Thank you for your time. Please do get in contact with us should you have any questions or wish to discuss your project needs further.